We'll be looking at transport across membranes. Thank you for watching the previous videos. I know you enjoy it. Now, today we'll be talking about transport across membranes, and we talk about transport across membranes, talking about the transport of ions, particles, molecules, atoms, smaller cells, larger cells through the cell membranes, and now through the cell membranes, we have about 5 transport systems I'll be discussing today. The first one, as you all know, is diffusion. Diffusion simply talks about the net movement of molecules from an area of higher concentration to an area of lower concentration than a concentration gradient. So once again, diffusion talks about the net movement of molecules, ions, particles from an area of high concentration to an area of lower concentration through a concentration gradient. Now we're talking about the second one, the osmosis. Osmosis, as you all know, is a random movement of water particles from an area of high concentration to an area of lower concentration through a semi-permeable membrane. I'll come again. Osmosis is the random movement of water molecules from an area of high concentration to an area of lower concentration through a semi-permeable membrane. But I'll be giving you another definition of osmosis. But before then, I would like to break down what we call water potential. Water potential is the measure of the tendency of water molecules to move from one place to another. Water potential is the measure of the tendency of water molecules to move from one place to another. So now, with this, I can drop the second definition of osmosis as the movement of water molecules from a region of higher water potential to a region of lower water potential through a semi-permeable membrane. Once again, I come. Second definition of osmosis can be seen as a movement of water molecules from a region of higher water potential to a region of lower water potential through a semi-permeable membrane. Now, breaking down some things in the cell, the water potential of a cell depends on the amount of the solute and the potential and the pressure potential. The concentration or the water potential in a cell depends on the solute of each solute and the pressure potential. Now, going down to pressure potential, the greater the pressure potential, then the greater the tendency of the water to leave the cell. The greater the pressure potential inside the cell, the greater the water molecules to leave the cell. So with that, we say water and pressure potential is positive by value. So the pressure potential is positive by value. Now for the solute, the amount of solute needed to increase the water potential of a cell, the amount of solute, talk about the solute now, the amount of solute needed to increase the water potential of the cell, and the solute is negative. So the more the solute, the value of the water potential will be negative. So the more the solute needed, the value of the water potential is negative. But for the pressure potential, the greater the pressure potential, then the positive the value of the water potential. Now the third one I'm going to be looking at is the facellated diffusion. Facellated diffusion talks about the movement of molecules from a region of high concentration to a region of lower concentration through a carrier protein. Like amino acid, they are responsible for the movement of molecules from a higher concentration to a lower concentration through a carrier protein like amino acid. So now, and again, they are large in size and they are polar in nature. So most of the larger sizes of particles or molecules or ions pass through the cell membrane through this transport type, which is called the facellated diffusion. Now the next one we're looking into now is the active transport. The active transport, as you all know, is the movement of molecules from an area of low concentration to an area of higher concentration through a transmembrane protein. The movement of molecules, ions, particles from an area of low concentration to an area of high concentration through a transmembrane protein. And then they make use of ATP as a form of energy, which must be synthesized into ADP and PI. So ATP, as you all know, is the currency energy of a cell. Full meaning of ATP, as you all know, is adenosine triphosphate. So it might have to be breaking down to ADP, which is called adenosine diphosphate, and also PI, which is called inorganic phosphate. Okay, now the fifth one we're looking into here is inorganic phosphate, as I said, the PFI. The fifth one we're looking into now is the bulk transport. Now the bulk transport talks about is an active process too. In this type of transport is an active process. I'll let you know why it's active as I end the definition. It's an active process that determines and helps the cell to ingest substances, particles, ions in or out, it's just out of the cell. We talk about the movement of particles through the cell in and out, and it's active process. Why is active process? Because it makes use of ATP as a form of energy. It makes use of ATP as a form of energy to stimulate the movement of substances to be excreted out the cell and to be ingested in the cell. Now we're looking at some basic factors here. So when a cell excretes a substance, such phenomenon is called what? Such phenomenon is called what? Exocytosis. When it says excrete a substance, called such phenomenon is called exo out, cytosis about the cell, related to cells, process of the cell, cytosis. Now hormones like insulin and neurotransmitter like adrenaline, they are what? They are secreted. They are secreted out of the cell. So they make use of, they are secreted by exocytosis. So get me again, the hormone like insulin. Insulin and neurotransmitter like adrenaline are secreted by exocytosis. Then opposite of exocytosis is endocytosis. When the cell ingests, when the cell take in a substance, is known as endocytosis. Now the cholesterol we're talking about is being cholesterol is being ingested. Is being ingested by endocytosis. Cholesterol is ingested by endocytosis. So that's just it. It's ingested by endocytosis. Now the phagocytes themselves, they ingest microbes every day. The phagocytes ingest microbes every day. Now when they ingest these microbes in our body, there's what we call digestive enzyme. The digestive enzyme breaks these microbes into peptides, which is known as protein. The digestive enzyme breaks this enzyme. So the digestive enzyme breaks the microbes into peptide, which is known as what? Protein. And these peptides are being what? They are what? They pass through a phenomenon which is called exocytosis, so that they can be what? Secreted out the cell of the body. Thank you for watching, and I know you enjoyed the video. I'd like you to shift it to your friends, and thank you for previous ones you have been watching. I'd like you to subscribe more, because more videos are rolling out. More videos are rolling out in a simple way where it can be explained in a nutshell. You get the basic information about what it's all about. So for this video is a transport across membrane. So once again, I'll list out the 5 transports across membrane I've just discussed. The first one is diffusion, the second one is osmosis, the third one is facilitated diffusion, the fourth one is active transport, and the fifth one is bulk transport. Thank you for listening. Love you all. Bye. My name is biochemist Armstrong. Thank you. I'm a Nigerian. Thank you. God bless.